asked to graph two variable inequalities, and this inequality is y is greater than 3x minus 1. Well, let's think about what we already know. What we already know is y equals 3x minus 1. So the only thing that's different is that this is an equality and this is an inequality. So what does that mean as far as the graph goes? Notice we have two variables. We have a y and we have an x variable. This actually is linear, and it means that when we have an inequality that we're actually going to have a region of numbers that's going to satisfy this equation. So let's go ahead and graph this, and then we'll talk about how we graph that. So the first place you start is you start at the y-axis intercept, which is b is equal to -1. So that's right here. So we're going to start there, and then we're going to do a slope of 3. So a slope of 3 is the same as up 3, right 1, or down 3, left 1. So let's do that. Up 3, 1, 2, 3, right 1, 1, 2, 3, right 1, 1, 2, 3, right 1. And then from here we go down 3, 1, 2, 3, left, 1, 2, 3, left. Okay, so if we were going to actually draw this line, we would take our ruler and we would draw a straight line through all those points. However, because we have this inequality, it means it cannot actually equal those values on the line. So that means when I draw my line, I'm going to draw a dashed line. But that's not all I'm going to do with this particular graph. There's more to it than that. Okay? So that's what my line looks like. It's dashed. Put arrows on the end because it goes forever in both ways. But it's also saying all values will be greater than 3x minus 1. So what does that mean? Let's pick a point. We're going to pick 2 points. We'll pick a point here. Let's pick this point. That's the point 1, 1. Okay, and then I'm going to pick a point here. Excuse me, that's -1, 1, and then I'm going to pick this point here, which is 1, -1. Okay, so I'm going to test those 2 points. So let's test the first point. So here we're going to do our test. We're going to test -1, 1, which is this point here. So that means y is 1. Is that greater than 3 times -1 minus 1? That's the question. So let's simplify this. 1, is that greater than -3 minus 1? So 1 is actually greater than -4, isn't it? So that tests to be true. Okay, so that's a point that's valid. Let's test this one. So here y is -1. -1, is that greater than 3 times, we're going to put 1 in for x, and then we have -1. A lot of 1's going on there. So is -1 greater than 3 times 1 is 3 minus 1? Is -1 greater than, that would be 2, and the answer is no. So a point on this side, in fact any point on this side of the line, if you were to test any point in this region here, would not satisfy this inequality. That means the region above the line, any point I pick in this region here, will satisfy the equation. So that means I have to make sure that I shade the region above the line. Okay, so another way of thinking about this is, let's go to my y-axis, right here at my y-intercept. When I'm thinking about my y-axis, if I go this way, doesn't my y values get bigger? And if I go this way, doesn't my y values get smaller? So right here, where are y values bigger? Y values are bigger this way. So that means everything above that line. Okay, so that's my entire region there. If I were to have this as a greater than or equals to, this line would be solid. Okay, so that's how we do it without a calculator, but let's do it with a calculator. Hopefully the calculator screen will show. So I turn my calculator on. Notice I'm in the y equals, so push the y equals and get this screen. Don't worry about that inequality right now. Let's go over and put in our function, which is 3x minus 1. So when I go to graph that, I just get a line. There I go. There's my line. In fact, that's the same line you can see that I graphed here. Okay? It's solid though, because remember, I did an equals to. So now how do I put that inequality in? Well, I want y to be greater than. So that means I want my y to be greater than. So I'm going to go over to my y, to where this line is right here. I'm going to push enter, and on this calculator it gives me a screen. On older models, it will then start changing the symbol the way it's going to change here. I'm going to leave my line blue, but I'm going to change this. So I'm just going to scroll. That's a thicker line. Now notice how this triangle is on the top part and that triangle is on the bottom. So the top would be greater than and the bottom would be less than. So I'm going to have it so my triangle's on the top. I'm going to go to OK. I'm going to push yes, that's what I want. So notice it changes it right here to be greater than. So if you have a different operating system, if you just keep putting enter, you want to do it until you get the triangle on the top. Now watch what happens when I graph it. So you can see as I'm graphing it, it's graphing the upper region of that line. So what I have to decide here is that line solid or is it dashed? Because there's no equal here, I have to remember that that line is solid. Okay? The last thing I want to show you is let's go to our table. So if we go to our table, we have a bunch of points that are in there. I have 1, 2 is a point, is not exactly the point that I had placed in there, but let's just look at 1, 2. Where is 1, 2? Here is 1 and 2 is right there. So it's including this line, this right here on the line, but we have to be savvy enough to know that that point does not exist. There are other points above it that do exist, but that one does not exist because it's right on the line. In fact, all of these points are points on this line. So that is our boundary, but it does not include those points. So you have to be very careful with that.